This is grade 12 advanced functions, combinations of functions unit. Welcome back to advanced functions, MHF4U 1. This is combinations of functions chapter. In this lesson number 7, we're going to use a variety of functions to model the real life situation of modeling different functions. So first question. So approximately 5,000 people live in Haleystown. One person in her school came back from March break with a virus. A week later, 70 additional people had the virus, and doctors predicted that about 8% of the town's residents will eventually get the virus. Model the number of people infected as a function of time in days. Okay, so first of all, we are given, let's say, in terms of, if we're assuming it's a linear, the issue that if we assume it's linear, it's not the proper growth. Okay, so I do want to write down, if assuming linear, the issue of it will be, it's the not proper growth. Okay, so therefore, then we could pick a point. So at 0 time, one person is affected. And then a week later, so 7 days later, 70, additional 70 people. So it will be 70 plus 1. So it's going to be 71. So assuming that X represents the number of days and Y represent the number of infected people. Okay, so I represented that as a point. Then the general equation is going to be Y is equal to mx plus b. Now we understand that b is going to be my initial value, which is going to be 1. One person was infected on day 0. And then 7 days later, 71 people got it. So we need to figure out what the slope is going to be. Slope, we know, is going to be change in y over change in x. And we understand that y2 is going to be 71 minus y1 is 1 over x2 is 7 and x1 is 0. And then you get 70 over 7, and which equals to 10. So we now found slope, which is 10. But we have to consider 8% of the residents will eventually get the virus. So that means 8% of how many people? 5,000 people. So that is 0.08 times 5,000 is equal to 400. So therefore, first let's write down the equation. Y is equal to 10x plus 1. But we understand how many people? 400 people. So 400 is equal to 10x plus 1. Why? Because we're looking for the time. Okay? They're asking time in days. So then I move this 1 to the other side. 399 equals 10x. X is equal to 39.9 divided by 10. Okay, so therefore, the general equation is y is equal to 10x plus 1, but the domain is, there is a time limit, 39.9 days. So for domain is that x can be any real number, because assuming that it's linear, but such that it starts from 0 days up until 39.9 0.9 days. And that is the representation of this word problem, assuming that it's a linear growth. Okay, so this is days. Now, what if we didn't assume that it's a linear growth, that it's exponential growth? Now, there are some issues again. Now, what do you think will be the issue if we assume that it's exponential? So we know that it's going to be a curve of growth. So what does that mean? It's really hard to predict the equation unless you are given a specific points of the data. And so limit is not built in. Okay, the limit is not built in. Okay, so because it's exponential, the approximation method will be occurring in this case. So let's see. So same thing. We understand that at 0 days, 1 person is affected. We just stated that X represents the number of days and Y represents the number of people. And then at a week later, 7 days, 71 people were infected. So if it's exponential, the formula, the standard formula is Y is equal to ABX. So in this case, the initial value, which is A, is equal to 1. That's my starting point, the y-intercept. And then what we could figure it out is we could plug in this point into the equation. So it will be 71 equals 1. Base, we don't know. That's what we're looking for. How much is increasing by? To the power of 7. And then 71 divided by 1 is 71. So 71 equals B7. So to isolate for B, we're going to take the 7th root to both sides. So you can cancel. So using your calculator, 7th root of 71 is going to give you 1.84, approximately. Okay, so now that we found the base, let's put it in. Y is equal to 1.84 x. Okay, so 1 is invisible. Now we need to plug in the numbers that we know. So we understand that 8% of 5,000 is 400 people. So let's plug in 400 as y, 400 people, equals 1.84 x. Now, again, it's really hard to equate the same base because we have a decimal. So what we're going to do, we are going to take the log to both sides. Log 400 equals, so I'm going to bring x to the front, x times log 1.84. So let's divide both sides by log 1.84. So log 400 divided by log 1.84, that will give me x. So when you punch it in your calculator, x is approximately 9.84 days. Okay. So it's totally different from linear. Linear, we said it's going to take about 39.9 days. But if it's exponential, it's very quick, 9.84 days. So what's the general equation? Y is equal to 1.84 x. And the domain for this restriction is that x can be any real number such that it has to be in between 0 and 9.84. Okay? So it's a big difference. Okay, now what if we are thinking logistical method? Okay, so If we are approaching in a logistical method, there's pretty much no issues. Why? Because this is the actual equation that we will be using for infection rate. So the infection rate for logistical method, the formula looks like this. Y is equal to C over 1 plus ABX. So this formula, you don't have to memorize it. It will be given to you. But you need to know what the letters represent. So C is called a carrying capacity. So carrying capacity in this case, we know that it's going to be 8% of 5,000 people. So the carrying capacity we're looking for is at 400. And same thing, we're going to use same 0.01 and 771. Okay, so what we're going to do, we're going to first figure out all the variables. So first step, let's plug in the values that we know. So I'm going to plug in 0, 1 into my x and y. So y is 1, 400 over 1 plus a, b, x is going to be 0. Okay. So then b to the 0 is 1. So therefore, it's going to be 1 equal to 400, 1 plus a. And then I'm going to move 1 plus a to the other side. You multiply. 1 plus a equals 400. A is equal to 399. Okay, so now let's plug in what we know now. So y is equal to 400 over 1 plus 399bx. And now what I'm going to do is I'm going to plug in 771 into the next equation. So y is 71 equals 400 over 1 plus 399. B, that's what we're looking for. And then x is 7. Okay. So therefore, I'm going to do crisscross, cross multiply. Okay. So then crisscross, so it's going to be 71. So 400 over 71 equals 1 plus 399 B7. Okay, and then I'm going to move 400 over 71. Make sure you carry all the digits, but right now I'm just going to put 5.63 minus 1 equals 399 B7, and divide everything by 399. Then you get 0.0116 equals B7. And you're going to take the root of 7 so that you cancel out. So please carry all the digits. And B is going to equal to about 0.53. Okay, so therefore, if we're approaching the logistical method for the equation based on this word problem, it's going to be y is equal to 400 over 1 plus 399 times 0.53x. Okay, so this is the final equation that will be applying for this word problem. Okay, so no issues, no limitations compared to whether if it's linear or exponential. This will give you the perfect model that will be able to approximate the number of people affected in a given time in days. Okay, so next word problem. An above water ground swimming pool in the shape of a cylinder with a diameter of 5 meters is filled at a constant rate to a depth of 1 meter. It takes 4 hours to fill the pool with a hose. Now make a graph showing volume of water in the pool as a function of time. Okay, so if we're making a table of values, a graph, so filling a pool, so this will be my title, underlined. So my x-axis, it's going to represent time in hours, because it's in hours. And then for y-axis, it's going to be the volume given in, because it's meter, so it's going to be meter cube. So we know that it's going to take 4 hours to fill the pool. Well, for the cylinder, the formula for volume is pi r squared times h. So pi, radius in this case is 5 divided by 2. Because diameter is 5, so it's the half of it. Square times height is 1. So when I calculate all this, you get 19.625 meter cube. So that is my volume. So I'm going to do 10 and 20. So approximately at 4, not at 20, but pretty much around 20. So this is at 19.625. And at 2, approximately near 10 hours, but just less than 10. And this is going to be a linear function. Letter B. So determine the equation of a mathematical model for volume as a function of time. Okay, so then that means we said volume is equal to pi r squared h. We know r is going to be half of 5 meters, so it's going to be 2.5. So pi times 2.5 squared, and then times 1, which is the height. Okay, and so if I have to simplify this, this is going to be 6.25 pi. Okay, and then, so this is going to be my volume. But we are looking at volume as a function of time. So what does that mean? So we have to say let x, so it's going to be let x be the number of hours. So volume over time, in this case, it's going to take 4 hours times x, the number of hours given. So therefore, the equation, if I want to use, let's say, y is equal to, the volume, is equal to 6.25 pi x over 4. And that should represent the mathematical model for a volume as a function of time. So then when will the volume of the water be 8 meter cube? So we're looking for time in hours, and we're given volume at 8 meter cube. So let's go back to letter B. The formula was y is equal to 6.25 pi x over 4. Then we know y is going to be my volume, which is 8. 6.25 pi, we're looking for time x over 4. So let's move forward to the other side. 32 equals 6.25 pi over x. And let's divide everything, both sides, by 6.25 pi. So 32 divided by 6.25 pi is equal to x. And when you punch that in your calculator, X is about 1.6 hour. So therefore, the volume of the water will be 8 meter cubed at 1.6 hour.